Hello, 7th standard. So today we are going to deal with our first unit, that is on physical quantities and measurement. So this unit was somewhat familiar to you right from your 6th standard, but I've all studied about physical quantities and how to measure them. So I'll just give a recap on it. So what do you mean by physical quantity? A physical quantity is something which you can measure. Anything which we can measure, we call them to be as your physical quantity. So when we measure a physical quantity, we always need a unit. Exactly. So we require a unit to measure a physical quantity. So in your 6th standard, you have studied about length, mass, time in your physical quantities and measurement. You have studied each of them as single chapters. But here we'll be learning on measurement of volume, area, density and speed in one single chapter. So we'll be learning as all these things in one single chapter, not in different chapters. Okay, so let us get back to our topic. Our topic is on measurement of volume. So I've come across this word volume for a long time. Okay, volume. What do you mean by volume? Now consider you're just taking a pen and try to fill it with your ink. You will find you can fill a limited mLs of ink into it. You cannot fill a lot of it. So it means that is the capacity your pen can hold. Similarly, you take a cardboard or a container and try to fill into it. Only the capacity which it can hold you can fill, not more than that. If you try to fill it, it will overflow out of it. So that capacity or the three-dimensional space which an object can occupy is called as your volume. So if you're going to insert a lot of stuff into it, you cannot insert it, it will automatically start to come out of it. So volume is defined as the three-dimensional space occupied by a substance. So all your three states of matter has this volume, that is your solid, liquid and gas. All these three has the concept of volume. You can fill you can put your chalk pieces or your cakes into a box. Similarly, you can pour your liquid, you can pour your juice or an ink into a bottle or anything till the capacity it has. Similarly, you can fill your gases into it. You have come across your LPG cylinder, all those stuffs. Okay, everything has its own limit till which you can fill it. So that particular capacity is called as your three-dimensional space which is occupied. So now think about an example where I have given you a tumbler and a jug. Okay, so which can have more capacity? A tumbler and a very big bottle I'm giving you. Okay, a small tumbler and a big bottle. So which can has a big higher capacity? Yes, the answer is your bottle. How do you say it has more? Because it can fit more tumblers into it. Okay, many tumblers of water can be poured into your bottle. So it is the capacity which determines the volume. Okay, we speak volume in terms of its three-dimensional space. That is the capacity. So some of the examples which are illustrated in your book, a mug and a bucket, and you also think about an auditorium and a normal classroom. So where people can sit in a lot, yes, it is an auditorium. Therefore, the amount of air in auditorium is quite large comparing to your classroom. So this is all about your volume. So now the definition of volume is nothing but it is your three-dimensional space occupied by an object. An object should occupy this particular space. If you go and sit in a space, that is your volume. Okay, a thin person will have a little bit of volume comparing to a person who's much more obese than him. So the next thing about your physical quantity is your units. So far we studied about volume. Volume is a physical quantity which I can measure. If I want to measure, I need a unit. So what is a unit? I have to measure it. Okay, so now listen, I told you your volume is a three-dimensional quantity, which means it is going to have x, y and z axis. Okay, it will have your x axis, y axis and z axis. Okay, it will have x, y and z axis. So it will occupy the space in all three dimensions. So you have studied in your maths what is the formula for volume of a cube or a cuboid. Okay, let us consider of cuboid. It is length into breadth into height. This you have studied in your maths, is or no? For sure you would have studied in your maths. Now consider, I'm just going to take an object that is a cube. It is cubical in shape. Okay, let the length of the cube is 1 meter. So cube means, what is your volume of cube formula? It is each side, that is length into length into length. So all sides are 1. Therefore 1 meter into 1 meter into 1 meter. So 1 into 1, 1. 1 into 1, 1. But meter into meter, it is meter square. Meter square into meter, it is meter cube. Can you see? Here it is power 1, power 1, power 1. So 1 plus 1 plus 1, it is 1 meter cube. Therefore, the volume of cube is 1 meter cube. So this is the unit of your volume. So what is the unit of our volume? We'll be using meter cube. Okay, we'll be using which one? 1 meter cube. Now, it will always have a smaller unit as well, because I am going to trying to measure a volume which is going to be in centimeters, a very little bit of volume. So in that case, I cannot use my meter cube all the time. So I have to use centimeters. So what you do, convert meters into centimeters, then find it. Okay, so shall we try that? Yes or no? Okay, now listen. What is 1 meter? 1 meter is 100 centimeter. Therefore 1 meter cube. What is 1 meter cube formula? 1 meter into 1 meter into 1 meter. So instead of this 1 meter, try to put 100 centimeter. 100 centimeter into 100 centimeter into 100 centimeter. So 100 into 100. How many zeros? 1, 2, 3, 4. Into one more 100, that is 6 zeros. So all the zeros will be put together. Centimeter, centimeter, centimeter. So 1 plus 2 plus 1. So it is centimeter cube. Therefore 1 meter cube is equal to 10 power 6 centimeter cube. You all got it? So which we call it as your cubic centimeter. Okay, so we also have the units of volume in meter cubes, cubic centimeters or cubic millimeters. So generally, okay, the general units of your volume. Your volume can be measured in cubic meter, cubic centimeter and cubic millimeter. Okay, so it is the units which we use for it. Suppose I have defined the value of a cube and I am going to have many cubes arranged one after the other. In that case, I can just add it and I can tell in terms of unit cubes. So now look at here, how many cubes are there? Totally 6. Therefore, what is the volume? 6 centimeter cube. And here 1, 2, 3, 4. Therefore, it is 4. Similarly, you add it and you call it to be as your 8 centimeter cube. So this is how we will use your unit. So boys, I'm going to give an example to show the importance of units. Okay, so consider 50 kg, 80 centimeter, 2 meter cube. Okay, so can you see the different units? Yes or no? 50 kg, 80 centimeter, 2 meter cube, 50 seconds. So by looking at this kg, it means I'm speaking about a mass of an object. I'm speaking some mass. Okay, so just by using the unit, I can identify it is your mass. Now look at this, centimeter. Where do we use centimeter? It can be a distance or a height, a length, breadth, anything. So it is going to be some factor which is related to your length. Okay, it is related to your length. Now meter cube. Just now I told you the unit meter cube is associated with your volume. So if at all you're going to speak about volume, what is the unit which I'm going to use here? Meter cube. And S stands for? Yes. S stands for seconds. So seconds means it is your time. So can you understand the importance of units here? So just by identifying the units, I can identify my physical quantity. So what is the SI unit of your volume? It is meter cube. Okay, what is the SI unit of volume? It is your meter cube. Now I can measure my solid objects. Now how I'm going to measure my liquid objects? What is the unit I'm going to use for volume of a liquid? How do I measure it? The volume of a liquid. So that quantity, we call it as your capacity. I've used this word in the starting of our class. That is the word capacity. Because we know liquids cannot take definite shape. They cannot have definite shape, but they can occupy definite volume. They can occupy a volume, but liquid cannot take a shape. In whichever container you pour, they can take that particular shape. You remember, you take a conical flask, pour into it, it will take that shape. You take any round flask, you pour a liquid into it, it will appear to be round in shape. So it means you cannot measure your liquid in terms of your, yeah, exactly. So what you have to use, you have to invoke another unit. So we call it to be as your capacity, the internal capacity of your object, of your instrument. Okay. So capacity is generally measured in liters or milliliters. For example, you consider, just take the juice bottles which you're buying, or the soft drinks, or the oil pouch. Okay, you would have find your oil pouch in your home, or the oil can. All these things in your home will be there. And ask your mothers to show some of the utensils which will have some markings on them. You will find it will be noted down in liters or milliliters. Just simple example, just go and ask your mother to show your oil can or your oil pouch. You will find it is written as 1 liters, 5 liters, 2 liters, 500 ml. So it clearly shows that particular pouch, okay, that particular packet can hold how much liter of volume, how much liter of oil into it. It is 1 liter of oil. So therefore we are going to measure your oil in liters. So here we have a simple calculation which shows your capacity. That is 1 milliliter is equal to 1 centimeter cube. 1 liter is equal to 1000 milliliter. That is 1000 centimeter cube. So I can relate my liters towards my centimeter cube. Got it? You can relate your liters to how much? Centimeter cube. Therefore 1000 liters is equal to 1 meter cube. Okay, so 1000 liter is equal to 1 meter cube. 1 liter is equal to 1000 centimeter cube. So these things will be using in your numericals. Clear? So 1 liter is equal to 1000 centimeter cube. So if I'm going to multiply by 1000, it will become, 10 power 6 centimeter cube. So this same thing we saw here, is or no? 10 power 6 means it is nothing but 1 meter cube. Therefore I'm going to use the same 1 meter cube. So it is called as your capacity. So there are various kinds of jars. Measuring jars are used for measuring your capacity. So if you go to your the ration shop, you can find they'll have different jar for measuring the oils, kerosene and all those. And in your laboratories also we have several apparatus, and all these apparatus will have some graduations. Graduation means it will have your markings just like how you had in your normal scale. You take your scale, you will find the markings like this. Okay, they are called as your graduations. You will have graduations like this. So it is called as a graduated cylinder. It's a beaker and it's a burette. So all these are your different kinds of instruments which we use in your laboratories. So the next thing is, whenever you pour a liquid into a glass container, you will observe either the liquid will bend downwards or upwards. Okay, there will be a curve. There will be a curve into it, and that is called as your meniscus. It's called as your meniscus. Okay, listen. Whenever you pour a liquid, you will find it has a curve. It forms a curve, and that curve we call it as your meniscus. So if that curve is showing downwards, it is called as your concave meniscus. The curve is downwards, it is called as your concave meniscus. Then I will take the lower reading of it. Okay, how do I measure it? By taking the lowermost reading of it. The curve is not downwards, but instead it is upwards. It is called as your convex meniscus. Then the reading should be taken in the uppermost part of it. Okay, and so liquids which wet the sides of your cylinder and it is curved downwards, it's concave meniscus. Liquids which do not wet, that is example is your mercury, and it is curved upwards, that is your convex meniscus. So the example of it is given in an activity. So now look at here, I told you have to take the lowest measurement of it. And look at the lowest measurement, it is somewhere between your 45 to 50. So this is the measurement of it. Now look at over here, it is somewhere between 75. So this is for convex meniscus. Okay, is it clear till this?